Hello, welcome and good evening. Welcome to our development live stream for September 2020. And today we're going to talk about the instance filter node that our patrons requested to be developed this month. And yeah, it's actually quite an interesting one. And I got most of that done already. There's some additions that I thought would make sense. And yeah, let's just show you the current state. And if you're wondering about the bananas, somebody on the Lightwave Discord mentioned minions. So yeah, this is for you guys. All right. Hello, Sakutsu. Hello, Laird. All right. So I've opened the audio node instances filter instances scene. That's a part of the sample scenes that you got to show how the audio frequency node works. And since this one has 80 instanced bouncing balls in it, I thought that would be perfect to test out the instance filter. We'll just go to a frame where you'll be able to see them. There we go. And I'm doing this in 2020, and that's going to be relevant in a bit. And hello, Ingo. All right, so this is a node, and this is the node graph that you currently get when you open the sample scene. And for now, I'm just going to add the new node, which is in the db&w section, additional. And there you see the instance filter. Double click and add it. And in this case, I've made sure that the user interface is going to be open outside of the node editor, so I've got more space. So I'll double click it. And you get to see this, which is just the current build. This is actually not a debug version, so if this crashes, I'll be lost. But it shouldn't. I tried most of the stuff. So this is very similar to the instance inspector node that you have already, which allows you to get the position and the rotation of a specific instance. The instance inspector node also gives you a graphical user interface to select an instance, and the instance filter uses the same interface. So the first thing you will need to do is pick an instancer that you're interested in, which is any item that has an instancer applied to it. This pop-up filters all of these out, so you will only see items with an instancer applied to them. You can select the instancer and it shows you how many instances there are on it. Actually, it should. Okay, that's a bug, but I know how to fix it, so that's something. This one has 80 instances. And you can turn on the instance picker like such. And that is going to show you a number next to every instance in your screen. Let me just maximize this. And if I scrub through the scene, you will see that the instances, the numbers move with the individual instances, and it starts at 0. This is the first instance to 79. That's the last one. It's 80 instances in total. So what you can do with a filter is you can basically select instances. So if I click on one, you will notice, that's a bit hard to see, I'll show you in the other ones, that the color of the number changes. It's a bit more saturated yellow. And the selection here says 0. So now you've selected instance number 0. I'll click on some more. And you see that the list extends. Now I've selected instance 0, instance 23, 24, and 25. And they're like in a bright yellow now. If you want to deselect an instance, you just right-click it. And it's being removed from this list as well. Left-click, add, right-click, remove. I did want to use something like shift-click or control-click, but for gizmos, which is the part of the SDK that I'm using here right now, Lightwave doesn't pass through the modifier keys as it should. Hello, Carm. Hello, John. Don't worry, I barely started. So, okay, so left click, add to the selection, right click, remove from it. And what you have selected reflects in this list here. And you can also edit it here. So if I want to, for example, add node 72, 73, 74, and 75, I get a crash. Don't ask me why, but I got a crash. Not happy. But yeah, that's probably because I just changed something. The instances, that's the normal instances that you set in the Lightwave scene. So at least you get to see some bananas when I crash, so that's something. So yeah, the instances are set in the Lightwave scene using the normal Lightwave instancer. This only allows you to filter them. So let me just load that scene again. There we go. All right. Open this. Go back and add the instance filter. Open the user interface. Select. See, this is because Carm and John are late, so I have to repeat this again. That crash was on purpose. I activate the picker. I select stuff, and yet this thing up there works as well. There's just some last minute bug in the code, and there we go. So I've got something selected. Right click to deselect, and you can also change how the left mouse button works. If you actually prefer to toggle a selection, you can just switch the mode here to toggle. And in this case, you left click on something and it's being selected. There we go. And if you left click again, it's going to be deselected. I was thinking, some people might prefer that to the other method. So yeah, let me just select a few here. So I've just selected instance 1, 2, 3, 4. I still need 5. That's this one. Oh, come on. There we go. 5, 6, 7, 8, 9, 10. The problem with the toggle is that if you double click really quickly, you might just select and deselect again. All right. So now I've got the filter node here. And currently this only outputs one value. It's an integer value. And it takes the current instance that's being rendered, looks at it, checks if that's in the filter list here, in the selection list. And if that is the case, it outputs a 1. If that's not the case, it outputs a 0. What you can do with that, you can type the numbers in as well, except that it's buggy right now, but you can, yes. All right, so let's go to the logic nodes, and let's go to the Boolean Switcher. And just so you know, I'm thinking about actually moving the functionality of the Boolean Switcher into the instance filter as well. So you don't actually have to add a Boolean Switcher, but for now, to show you how it works, you have to. So I take the filter output and put that into the Boolean Switcher. And as many of you know, what the Boolean Switcher allows you to do, it allows you to attach inputs and select either one of them and pass it through depending on the Boolean input, on whether it's 0 or 1. So what I'm going to do in this case, I'll just add a color node. Sorry, that's off screen. And I'm just going to give it a nice green. We all like green, right? Okay. So I'm going to attach this to the new input, which adds 2 color inputs and a color output. And I'll attach the other color input, the gradient, to the color false, and output that to the principled BSDF. So essentially what this does is the instance filter checks if the current instance is in the list to filter, is one of the selected instances. If that is true, then it outputs a 1 value, which goes into the switcher. If the switcher gets a 1 value into the Boolean, then it's going to pass through whatever is the input of color true to the output color, which in this case would be green. If the instant filter doesn't find the current instance in the selected list, it's going to output a 0. And in that case, the Boolean switcher is going to take the color false input, which is the gradient, and pass that through to color. So this basically switches the color used by the surface depending on whether the instance is in the filtered list or not in the filtered list. Hello fish. So, and just so you can see what this looks like when you render it. Yeah, it didn't take the 0th one, or that could be a mistake on my side. But that's a bit odd. Yeah, it doesn't have the 0 in there. And it doesn't have the 8. But basically the blue, let me just turn off the motion blur to make it a bit clearer. All right, and maybe even change the backdrop while we're at it to make it even clearer. Oh, why doesn't Lightwave? Okay, odd. All right. So what we've basically done here is we have manually selected these instances, the green ones, and they get the green color, and the other ones get the color from the gradient. And you can do a lot more with the Boolean switcher. For example, if I just disconnect this, I'll just connect the original color back in. All right. This just gives me the blue spheres. And what I'm going to do now is I'm going to attach the principled BSDF material. And I'm going to add, let's say, car paint material. Why not? Which I think by default is red. And I'm going to say if the current instance is in the filter, then you apply the car paint. If it's not being filtered, then you apply the principled BSDF, take the output of this, put it in here. And now you see that the spheres that we have selected use the car paint material, and the other one use my normal principled BSDF. And if I go back to a dual view, let's turn off the picker. No, it doesn't want to. There we go. All right. Go to texture site. Yeah, that's okay. If I activate this again, activate the picker, and that might work, might not work. Yeah, it looks like Lightwave doesn't like me picking stuff while rendering. So that's my second crash, which is good. I'm gonna write that down. Picking while VPR crash, and the other one was numeric data entry that crashed as well. Yeah, it doesn't like this at all. All right. I think I've broken Lightwave. To be fair, I've been working on this until 15 minutes ago, so that's kind of expected. Yeah, no, that's a second crash already. Um, you can kind of animate the selection if you have like multiple filters and use booleans to combine them, for example. But yeah, there isn't anything like setting keyframes on the selection. That doesn't work. But yeah, essentially the idea is you have multiple instances. You can select them manually, and you can basically turn an instance into like a hero instance that you would like to texture differently, give a different color manually as opposed to random colors, things like that. No, they usually don't react to crash reports by third parties. If there is one, then you send it to the developer of you don't send it to the developer of the plugin. You give the developer of the plugin steps to reproduce it, and then we usually try to um, find out what's happening, see if it's on our side or on Nutec's side, and if it's on our side, we fix it. If it's on Nutec's side, we usually build like a specific test case for them. That makes it easier for them to find out what the issue is. Um, all right, so I'm back at square one, which is perfectly fine for now. Because one thing I found while testing the filter on Lightwave 2020, which is why at the start of the stream I mentioned Lightwave 2020, I found out that all of a sudden the coloring of my spheres doesn't work anymore. Normally, how this scene happens, and if you've seen the development stream before on the audio frequency node, you probably know this. It takes the ID or the index of the current instance, divides it by the number of total instances, which is 80 in this case. So the result of that is a number between 0 and 1, 0 for the first instance, 1 for the last instance, and it puts that into the normalized spectrum input, which goes from 0 to 1 as well. So basically the first instance gets the low end of the spectrum and the last instance gets the highest end of the spectrum, and the instances in between are driven by the spectrum values in between. And it uses that as a spectrum input for the audio frequency node, which outputs an amplitude, which in turn changes the color of the surfaces. And as you can see here, no color is changed. One thing I found out is that the ID index in 2020 is different from the ID index in 2019. Because if I load this scene in 2019, I get the colors that I want. And just to prove that, let's just open 2019. Load the scene. Come on. There we go. That's 2019 on the other display. Computing the FFT, yada, yada, yada. So this is 2019. I'm going to go to a similar frame. And if I activate VPR, I get the colors in the spheres. So the gradient is working as it should, and it's using exactly the same, it's the same scene, it's using the same nodal setup. But the value that's output from the ID index here is different. So one thing I added like half an hour ago is we now have under additional a instance info X node, as in extended, and we'll add the other ones that are here as well. But this actually gives you a proper index, which goes from 0 to whatever, regardless of the version of Lightwave that you're using. The ID is essentially a more or less random number, I suppose. What's interesting is this also gives you the total number of instances on a specific instancer. And it also gives you a fractional index, which is what I'm computing here. So the fractional index will, regardless of the number of instances, give you a number from 0 to 1, where again 0 is the first instance, 1 is the last instance. So in this case, oh yeah, and one thing, this node actually requires you to select an instance to work on. And this is because while rendering, if, for example, Lightwave is shading an instance, the node graph itself doesn't know which instancer is being used. It only knows that it's rendering an instance, and it gives you the item ID of the item that's being instanced, but it doesn't tell you where the original instancer is, and I need that information to get the total number of instances. So that's why you actually have to select an instancer here. And if I now take the number, the fractional index, and just put it into my spectrum, I get my colors. So that basically allows you to get rid of that whole divide thing here. And you can directly feed the audio frequency node with the fractional index. Yeah, let's go back to the instance filter, although I have to say there isn't that much more to say. Pick the instancer. And yeah, one thing I should not do is actually run that while VPR is running, at least not for now. Oops. You select your instances. Let me just select the first, maybe the last 10 as well. There we go. Turn off the picker. And I'm going to swap out the materials now. So I add a car paint node. There you go. And a Boolean Switcher node. Why is this capitalized? Okay. No, it's, yeah, there we go. And put the car paint as the new material in there. The other one is the false material. Put that into the output. Take my instance filter output and put that into the Boolean. And Control F9. And there we go. We've got some red spheres. Let's just change the color because we all like green, right? And there we have some green car paint on those spheres, and everything else are spheres driven by the audio frequency node. So yeah, that's how the filter works. So basically what I want to add to this is the same functionality as you have in the Boolean Switcher. So you would have a new input here, and whatever you connect with that new input is going to produce two inputs and one output, and you can switch between a filtered and unfiltered version of whatever it is. And since it's going to be like the switcher, it doesn't matter if you attach colors to it or vector or scalar value, everything is going to be switched. Yeah, that would be more like Carm said would be neat if an effector could dynamically select instances, so instances could be painted in animation. Yeah, that would require quite different logic because you would basically have to define an area of influence, check all your instances, see if they're within that area of influence, maybe with a soft fall off or something. It's probably relatively easy if you just want to, basically filter instances within a sphere of influence around a certain point. Because it's relatively easy to compute if an instance or a point is inside or outside of a sphere. Anything more complex than that could be fairly tricky to do, especially if you want to say, like, use an arbitrary volume like a mesh or something, and please change the or switch the instance if it's within the mesh or outside the mesh. That's tricky, very tricky. Definitely outside the scope of anything we'll be doing here. But yeah, something like an effector, a spherical effector thing would certainly be fairly easy to do, although it could get slow with lots of instances. Because I don't think there's much you can pre-compute where you could like pre-compute the selection per frame or something and not per single evaluation of a pixel of a surface. But yeah, Ingo, I just noticed that the same thing with the sample scene in the blue spheres. But now I know why. I think the scene was created just before 2020 came out, so I never really checked it there, and I didn't expect that to change. Um, well, it could, but that would basically be some kind of rectangle that's extruded vertically or in the third dimension, and that could work as well to animate a selection. Tricky, but yeah, not impossible. So yeah, I'm gonna update the sample scene, I suppose, with that new instance information node. Um, yeah, so that's the current state. 2 bugs to fix. Um, some small stuff to add to the instance information, and also adding the Boolean Switcher code or most of that to the instance filter itself. Um, I don't think I'll be able to add more to the whole picking logic. Um, except, yeah, you've got the option to toggle how the left mouse button works. I don't think you actually need an option for the right mouse button. Um, but yeah, that's essentially the current state of things. Do you guys have any questions? Anything that wasn't clear? I mean, I've just been talking for 30 minutes again. And no, Dagmar, there's not going to be any live bug fixing today. I probably can, Steph, but if I do, then Dogmore is going to whack me because that would be the third crash in a developer stream, and yeah, that would be a first time, so I won't. Okay, Ingo is asking where I can set the frequency of the audio that manipulates the parameters. Um, what I'm doing right now is I'm using the nodal inputs in this case. So the 3 inputs you have that basically determine which frequency is currently used. The first one gives that's where you input a straight frequency in hertz. So 10,000, 5,000, 44, well, yeah, not 44, Nyquist limit, but like 20,150 for bases, things like that. Spectrum normalized is also the direct frequency, but normalized from a value from 0 to 1. So 0 is like the super low base, 1 is the high frequencies. That doesn't directly give you a frequency to input, but you can basically use the whole range and use it with a number from 0 to 1, which might be the output from, let's say, a texture. You could use like an alpha channel value, which goes from 0 to 1, to pick a frequency, which, if it's normalized, also goes from 0 to 1. The spectrum is a little bit different because if you look at the user interface, you will notice that, or that's actually in documentation, is the spectrum that's being displayed here is not like a linear, this is 0 hertz and this is 22 kilohertz, but it's actually split up using octaves. So you have like 1,000 kilohertz or so is probably somewhere here, whereas if this was 22 kilohertz and you would use the frequency straight, then 1,000 kilohertz would probably be here. But since our hearing is much more susceptible to changes in low frequencies as opposed to high frequencies, it actually makes sense to put that into octaves. So the difference, or the bar width down here might just be a couple of hertz, whereas on the right-hand side, let me just extend this a bit. No, it doesn't work. And whereas on the right-hand side, where the high frequencies are, it might be a couple of, here we go, it might be a couple of thousand hertz in a bar. So the normalized spectrum takes also a value from 0 to 1, but it doesn't map it to frequencies from 0 to 1, but it maps it to the individual frequency bins, what is what I call them, from 0 to 1. And that gives you a much more natural response to the frequencies. No, octave, not octane. This is audio. And if you don't use the inputs there, let's say you want to have a fixed frequency that you want to check, one option you have, well, you have the frequency mode here, which is either a single frequency, or you can use a range of frequencies. So, I want everything from like 5,000 to 6,000 hertz, and it can use the average of that, the average volume of that range, the peak volume of that range, or the smooth option basically puts like a Gaussian curve on that, so that the volume in the middle of that range is more emphasized than the ones on the sides. And if you use any of these frequency modes and don't use any of the inputs, you can actually use the picker here. And that's where you can actually manually select like a single frequency to use, where you can select your minimum decibel levels or your maximum decibel levels, or you can switch over to a range and then select the whole range of frequencies. That's if you want to do it manually. Or you can just enter the numbers here, but this gives you a good indication of which part of the audio file you're actually selecting and what the numbers represent. And you can also scrub through so you can see that, how the waveform or the amplitude changes within your selection. So Yeah, very fancy. You have a lot of options there to define which frequencies you want to use, from manual selection to various parts of automating it by using something like instance IDs or whatever. That was off topic, but super useful. And you're welcome. Oh yeah, and also, since we're talking frequencies, um, if you look at the outputs of the node, it automatically gives you a bass, mid, upper mid, and high output. The frequencies those correspond to are listed in the documentation. So if you're like super lazy and you just want an audio file and you want the bass from that, then you can just use the bass output and forget about all the other settings because you don't need them. Maybe the minimum and maximum decibels to exaggerate or emphasize things, or maybe the boost setting, but you don't have to pick any any frequencies to use any of the bass to high outputs. And you can also use those with the channel modifier. That also gives you access to either a specific frequency or the bass to high outputs. So those are essentially the lazy settings, but sometimes all you just want is a bass. And why fiddle with the frequencies? And the basic idea for that was, to find something that is on the one side as easy as possible to use, but then again, it's audio, so you actually want more control as well. Yeah, that's pretty much all I have to talk about. Ooh, nice motion blur. Um, that's really all there is for now. Yeah, so instance filter will have the switcher included, which I think makes a lot of sense for the filter. And you will still have the filter output to use with the switcher and combine with other things, with other nodes from the logic nodes series. Because if you go to the db&w nodes, here you have the whole set of the Boolean comparison logic and rate type comparison and stuff like that. So you could even do things like, I don't know, change the color of an instance, but only if it's selected and it's in a reflection. So if you see it directly, it's using the original color, but if it's selected and seen through a mirror, then it gets a different color. Not sure if that's ever useful, but that's something you can do. It's just the first thing I could think of. Or if it's seen through a refraction or whatever. Um, so yeah, yeah, I think that's it for now. The small glitches that I still have in the filter, they're basically because I've been kind of fixing issues or not fixing issues, but modifying things in the instance filter, in the instance info X, and in the original instance inspector. And because they have some very, very similar code, and I just have to make sure that they actually end up using all the same code and same logic. Ingo, do you just thinking about what node I can attach this function to? Any parameter that has a node can be used for that. Well, right now, you would use the switcher node for the filter. Eventually, the switcher node is going to be a part of it. So, for example, if you want to change, let's just go back to the original material. Let me try this again. All right, so this is the original. Is that the original material? Yeah, it's probably something wrong with the. Oh yeah, okay, good, good. This is the way it's supposed to be. All right. So basically this is the original again. And in my case, I'm using a Boolean switcher. And the Boolean switcher in turn allows you to basically input any type of input, and it creates an output for that. Yeah, you can. Yeah, you mean for the audio frequency? Yeah, sure, sure. You could even do things like, I don't know, um, take even textured colors, for example, and use those. I mean, apply like a texture to a surface, and then use the applied color on the surface to drive the or to select the frequency, and then use the output of the frequency to drive the, I don't know, displacement. For example, that would work. Yeah, I mean, this displacement value here. So it's essentially up to you how you hook up all the connections. And I mean that's the nice thing about that whole nodal workflow, the fact that you can actually get outputs from a node, modify it with something else, then use that again in turn as an input for something else, and so on. So yeah, and with the instant filter, it's kind of the same thing. Oh, sorry for that, low fish. Thanks. Yeah, and as I said, currently you have to use the instance filter with the Boolean switcher, but that's going to be added to the main node. Then you will be able to say, you know, okay, I want to change, use the instance filter to change, yeah, maybe a color or an alpha value, or where is it? There we go. Even a position, and you know, things like that, and you'll be able to attach multiple node connections to the instance filter, and you will have two inputs each, and one of these inputs is going to be used if an instance is a part of that filtered list, and the other input will be used if that instance is not a part of the filtered list. And I will also going to add an option to just invert the selection, so that you don't have to rewire all of these connections here. If you find out that you have to, that you've done things the wrong way around, you can just, you know, press invert or something, and it's gonna switch the whole logic. Oh, you will get a link actually the same link is going to be valid once the stream is over, so you can rewatch it as often as you want to. No, it doesn't show you the number of emitters in a particle. I mean, the number of particles, because that would be a very different thing. This is just for instances. Having said that, if you're using particles to create instances, then you will get to see the total number, of course. It's just that in this case, I've just used like a circular spread to create the instances, but if I would use particles to create those instances, then the new instance info x node is going to give you the number of instances, which is the number of particles. So yeah, that's pretty much all I've got to say today. So if you have any more questions, because if not, then we're going to be looking at some more nice yellow bananas. And oh, hello, James. And yeah, as well, Discord would be the Q&A session, but not the public development stream. but we surely can meet on Discord afterwards, after show. Sure, sure. So for all the patrons, after show in our Discord voice channel, right after this finishes. Yeah, we're gonna party and have bananas. Um, Great. What was I going to say? Oh, yes. For all of you that haven't yet, please not just like, but subscribe as well. We're really, really close to having 100 subscribers on our YouTube channel. And once we get there, we'll be able to pick our own URL, which is, yeah, the first step to YouTube fame. So any subscription is greatly appreciated. And yeah, with those infamous last words, I'll leave you to it. Have a nice Friday evening. Have a nice weekend. For all of you patrons, we're going to see you on Discord, hopefully, where you can follow development. For those of you that aren't patrons, why not? The link to our Patreon page is below this video. And yeah, so yeah, exactly. Subscribe with all your fake accounts. We are greatly appreciated. So thanks a lot to all of you. Good evening, good night, and bye bye.